Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve question number 44 from GATE 2014 exam. In this question, it was asked is the Hamiltonian of a particle of mass n is given by these expressions. Which one of the following describes the motion of particle in phase space? So we have to calculate what is the trajectory of particle in phase space. So best way to calculate the phase space trajectory is by taking its potential energy. So we have given a total energy which is kinetic energy plus potential energy. Since P and Q are generalized coordinates, so just for simplification, we can replace this generalized coordinate by x in px. So px is our momentum now and x is the x-axis. So our potential energy is given by the expressions minus alpha square by 2. Now if we plot your potential energy, this is how it is look like. Dx versus x. It's an inverted parabola. And we know that whenever if you place a particle and you slightly displace it from this position, the particle will move far away from its equilibrium positions. So at this point, we always have a unstable equilibrium point. And the momentum at this point is away from the origin. So whenever since total energy is going to be conserved here. So whenever we have momentum P, which is small, so this is how our potential energy is look like. And whenever we have small value of small Vx to compensate it, potential energy P square by 2m has to be large. And whenever we have Vx, which is larger to compensate it, we have P, which is greater. So P and Vx have an opposite kind of relation to make the energy is to be conserved. So whenever we have potential energy maximum, we have momentum P is minimum, and when we have the potential energy minimum, we have momentum P as maximum. So this is the graph for phase space trajectory. Since this is true for the positive value of P as well as negative value of P, since energy is contained P squared term, so we have the phase space trajectory in both positive P and negative P, and it is also true for positive X and negative X, since our potential energy will contain X squared term, so it will be same for positive X as well as negative X. But the main part is the direction. So there is a thumb rule for direction. If we have P positive, then the direction is always going to be towards positive x-axis. For example, in this quadrant, we have P positive, so direction is toward positive x-axis. However, in this quadrant, the P is negative, so whenever we have P negative, the direction is toward negative x-axis. So direction is toward negative x-axis. So if this is the separatrix with separate different kinds of phase trajectory, so it will have this kind of arrows. It is away. So this is the towards and this is away. So this is the correct expressions for the phase space trajectory.